team number 7. The members of the team are Erin Silva, Uriarte, and myself, Cerna. And today we're going to present to you innovative systems. Well, nowadays there's a lot of research and there's an engineering challenge indicating that the idea of creating a robotic platform that we can control by thought is that. So we want to take a part of this. We want to attempt to be able to control a platform by thought by using brain function, facial muscle, and minimal movement that we can recognize and analyze. When it comes to the work out there, as of right now, Honda Asimo, March 2009, and they presented their new project, which is basically to enable brain function control capabilities for that robot. What they're attempting to do, as you can see, they're going to use infrared and electroencephalographic and brain-machine mapping in order to make the robot create 4 different types of movement and even clapping. Now we're attempting to do something similar, much lower scale, but we're going to use 2 different systems, the OCC neural impulse sensor and a Nintendo Wiimote. With that, we're going to enable a robot to be controlled wireless, so that means freehand, and it can have instinctive control. What we're trying to do this is that if somebody that can, they have limited body movements, they will be able to control a platform that can do different things for them. So what we're trying to do is to translate this to this robot so that can be implemented in a larger scale. And now to present the different components, Erin Silva.
So the platform that we chose was the Dr. Robot Dr. K8080. We went with this one because it was for surveillance, and this one had a webcam installed already into it. And within this we have 6, the platform that we're using has 6 ultrasonic sensors. Basically it's going to detect an obstacle in front of it so it won't actually run into it. It has 2 degrees of motion. Within the web surveillance, it has 4 degrees of motion as well. To control the platform, we are going to be using the neural impulse actuator. And from the name itself, it sounds like you're going to be controlling it fully from the, but in reality, what it does, it can read facial muscle, and within that, we can control like movement with your jawbones, and also your eye motion, and also your eyebrow muscles. The actuator, it has alpha and beta wave readings, so it can basically, you can also use that to control when you're relaxed. You can control the platform when you're relaxed, when you are angry, or when you are excited. And then, I'm sorry. In order to control the web camera, we're going to be using the Nintendo Wiimote. And as everyone knows, the Nintendo Wiimote, it's compact and it's very intuitive, and it has multiple accelerometers and also position sensors. And we're going to be using that, we're going to demonstrate it in the video, that as you use the Nintendo Wiimote, the actual camera moves to the 4 degrees of motion that it has.
I'm going to be talking about the flow control, how the system was programmed to work. So basically the way we set it up is we have 2 inputs. We have the Nintendo Wiimote and the neural impulse actuator, which are sending the signals into the system. From the neural impulse system, we're sending the data back to its actual software. So the neural software, which is simulating a keyboard, which sends it to our program interface and down to the robot. The Nintendo Wiimote was a little more tricky because there's a lot more proprietary software and hardware that companies don't allow us to use. Don't allow us to access and use. So we had to take a little bit more of a detour by connecting it to Bluetooth of the computer, using Blue Soleil to understand the Bluetooth commands, Glowify to interpret the signals from Blue Soleil, and then from Glowify we integrate again the keyboard simulator back to the interface and to the Robot 8080. Here we can see the actual module we created. The module allows the user to use the keyboard itself to control the robot, and at the same time by clicking the buttons. Because we created the NIA to use neural impulse to create keyboard inputs, and same thing with the Wiimote. The keyboard inputs the computer will normally read if I press W. It's going to interpret that as you clenching your jaw, make the robot go forward. That's the final way in which most motions. The eye control and the head control are just being controlled by the degrees of freedom of the actual Nintendo Wiimote. Here we can see a multimedia display controller that's the interface with the webcam. You can actually see where the robot is. And for one of our testings that we had the user just from the computer itself navigate the robot across of ARC, and we actually got it to different cubicles and started spying around different people what they were doing. So the system itself works, and then once we start integrating the other two apparatuses, we noticed that we're getting some mixed signals because of noise within the room, electrostatics. Now, we started looking at other products that were available to increase neuro impulse actuation, and we found this device. A company, it's Neuro Impulses. They make this has 27 sensors. Has 27 neuro impulse sensors. So that's 27 as opposed to the 3 we have in this system right here. And now, not only does it have that, it has 2 gyroscopes and a few accelerometers within the system. So now you can get more accurate motion, but also through thought. It's a lot more accurate than what we have at this moment, but we do have a system that gives you, that demonstrates the concept we're trying to illustrate. Basically, thank you for your attention, and now we'll move on to the demonstration when we're ready.